Today we're going to be completing the intro to Python with Heatmaps activity. So just to start off with our environment, you should always clean up the variables using this broomstick on the upper right side, just so that it doesn't interfere with anything. And just start off by running this first code block that kind of gets us set up in Python. And it's always important to save your own file and keep this original. So you can go to File, Save As, and change it to your own initials, as I've done here. So just starting off, we're going to start with our dataset empty cars. And basically we're using a Python library called pandas to import this into this variable. And using this line of code, we're only including the columns that have numbers as the results. And there's many different examples of columns, but each row represents a car and each column is a feature of that car, like the miles per gallon, the weight, the horsepower. And these are all represented by a specific number that intersects the specific column of the feature and the row. So if we just want to see the first 5 rows of the dataset, we have to do empty cars.head. And as you can see, oh, forgot to run this. And make sure to run your lines of code. As we can see the first 5 rows. So like Mazda, we can see the miles per gallon is 21.0. Number of cylinders is 6. And that way you can kind of have a whole data table. But before we actually graph it, it's always good to actually inspect the nature of the data. Like for example, what are its dimensions? What are all the column names? And what type of array is it? So we can just run these lines of code to see that the dimensions are 32 rows by 11 columns, meaning 32 cars and 11 features. These are the column names. And this is the type of class empty cars is. It's a pandas data frame. So this is some R code, but this allows us to see the entire dataset in a separate tab. Yeah, as you can see, we can see all 32 cars, 11 columns. Yeah, you can also get help on Python functions through this function right here, browse URL. And you might have to a new tab. So this is another Python library called Seaborn, and you can use that for other for Heatmaps specifically. And this website can kind of just tell you about all the parameters and everything. So the difference between R and Python here is that the heat maps in R just can directly be made from matrices, but for Python we have to convert to like a NumPy array, kind of to mirror how we work in R. So in order to create a NumPy array, we obviously have to import NumPy as MP. And we convert our array to a NumPy array and save it as data. So now running this line of code, we see that this is a NumPy array and the type is a float. So just dealing with some basic variables, if we assign a variable x the value of 5 and we print it out, if you guess, it's going to be 5. So yeah, we can assign things to each other using the equal sign in Python. So as you can see, we've imported our library Seaborn for our heat map, and we've also imported another library called matplotlib. So we are saving our cluster map with the variable empty cars with some other extra um, stylistic choices, and then we can also set the automatic axis titles just to make it a bit more organized, and tick label sizes. And this command basically just makes us able to actually see all this. So as you can see, we have ourselves a heat map with all our cars and all this. But it obviously looks pretty uneven. Like all of this is dark, all of these have much more ranges. So there has to be a problem. Like we can't really understand the patterns. So this is where scaling comes in. And just for one example, we can compare the scales of two different features, cylinders and disp. So if we just print this out, we can see cylinder goes from 4 to 8 and displacement 71 to 472, which is a significant difference. And you can just see we took the cylinder column from empty cars and found the minimum and the maximum. So we have to use another library in Python to actually scale this. And this one is called sklearn. Sklearn, which actually stands for scikit-learn, I'm pretty sure. And once again, we're saving it into a variable with data scaled with and making it a pandas data frame with the scale function. And if now when we run this, it will not show anything, but we can just compare it through this code box. So before scaling, you can just see how varied these numbers are. But after scaling, there are all these like decimals that fall into a certain range. And this is perfect for making heat maps. So now we're going to try using our seaborn function, sns.clustermap, and putting our data scaled instead with all our same stylistic choices. So in running this, we can see now it actually looks like there's a pattern. Like all of these areas are lighter, like maybe, and all these areas are darker. We can clearly see two clusters form. And I'd say it's pretty much more informative. Another thing we can do with heat maps is change the color. So we have a list of palette names in this list right here, and we can kind of just set these. So we can kind of just get a preview. I think what we were using before is Rocket. So we can try changing some of these names. So greens could maybe be reds. So I think we can just change it like this. Reds. And let's try this. And as we can see, it's all nice and red now. So now we're on the challenge questions, and we can again change greens to another palette. Let's try Mako. And then the same stylistic choices. And then as we can see, we have a pretty nice visualization. Another thing we can examine with the pandas library is the correlation of different variables using this core function. So we have our column mpg and we do .core with weight, and we can kind of determine how correlated are these variables. Like maybe does increasing mpg decrease weight or increase weight, or does it have no effect? So we get a correlational value of negative 0.86, which is approximately negative 1. So this means they have a strong negative correlation. So maybe as you increase weight, the MPG decreases, which if you think about it makes a lot of sense. If a correlational value is more near 0, that would mean it has like not as much effect. But in general, it's important to understand that correlation is not the same as causation. So we're importing matplotlib again, and this time we're making a scatter plot for each car, just to kind of visualize our little correlation. So we make a figure, and you use the function scatter with weight and MPG, and we can just put labels. And then, as we can see, it kind of forms kind of like a line with a slope of -1, approximately. So another thing we can do with Python is make a correlation matrix. So considering that we have 11 features, it would be pretty hard to make a separate graph for every feature against each other. So this is where like a correlation matrix would come in. Like it can do that. It can create the correlation for each feature and kind of put it on one matrix, so just so we can see it all in one place. So we can, so how we would do this is just do empty cars dot core without the other columns that we had earlier. And yep, now we can see, of course, MPG versus MPG is 1, MPG versus cylinder is this. But yeah, we can just easily compare the correlations for any two features. Now we are going to make a heat map of the correlations, so it's much easier to visualize. So again, so we're using the Seaborn SNS.cluster map, and wow, red over here, like a darker red, a warmer color, probably represents a positive correlation, while blue represents a negative, and more colorless is closest to 0. So the same methods we use today with cars is very similar to what scientists do with actual patients, except often data sets are much more complex or some missing values.